Dear students, good morning. It is a class 10. Once again we are discussing the electricity, and it is a lecture 4. Today the topic which will be discussed, that is the electric potential. To discuss the electric potential, students, we must know about the electric field. What is an electric field? The electric field is the region around the electric charge. It is the region. Suppose that here plus q charge is kept, then the region around, see the region around the electric force of attraction or repulsion can be experienced. The force of attraction or repulsion can be experienced. Okay. Now in the electric field, the force of attraction or force of repulsion will be experienced. So now we will discuss the electric potential. The electric potential at any point in an electric field is work done in carrying a unit positive charge from infinity to that point. Suppose here we are having the plus q charge. Here it is the capital Q and it is positive. Here plus sign is. Now suppose a test charge we have, the charge on which we perform the test. It is the test charge and it is the plus q. Here it is the test charge and plus q. Now suppose that you carry this charge from this point infinity towards the electric field in this direction. In this direction, you know. Okay. Now as you will come closer, as you will move this plus q charge from this point infinity towards the electric field, you will experience a force. You will experience a force. Now the force will be increasing, and here the force you are experiencing is more. Now we start considering it. Here in this region the force was negligible. But here you experience a force. And what type of force it is? It is the force of repulsion, because this one is the plus q charge and this one is also plus q charge. So now you have to do some amount of work in moving this charge plus q towards this charge. I mean the plus q test charge, when you will move it towards the charge plus capital Q, you will experience a force of repulsion. Now you have to do some amount of work in carrying this positive test charge towards the plus q. So work done by you in an electric field, the work done by you in an electric field in carrying a unit positive charge from infinity to any point in the electric field will be defined as the electric potential. So according to the definition, V, this is what? V. This V equal to W by Q. Suppose that if you do the W amount of force, W amount of work in carrying the charge from infinity, the charge from infinity to the point in an electric field, then the W amount of work is done and charge is Q. So V equal to W by Q. V equal to what? It is W by Q. V equal to W by Q. So electric potential at any point is a scalar quantity. What is the electric potential? At any point is a scalar quantity, because it is the amount of work done in carrying the unit positive charge, and its unit, I mean SI unit, is volt. What is its SI unit? Is volt. You have to define now volt. Electrostatic potential or electric potential at a point is said to be 1 volt when 1 joule of work is done in moving 1 coulomb of positive charge from infinity to that point against the electrostatic force. Suppose that if you are doing the 1 joule of work in carrying 1 coulomb of charge, here it is 1 joule of work and you are doing the work on 1 coulomb of charge, then the electric potential will be 1 volt. Electric potential will be 1 volt. Now we will discuss about the potential difference. What is potential difference? Suppose once again we come to this point. Suppose that 1 coulomb of charge is carrying from the infinity to the point B. Once again, the same amount of charge, I mean plus Q, you are carrying from point A, carrying from infinity to point A. So where you have to do the more work. If you are carrying this plus Q charge, I mean test charge, from infinity to point B, it is farther from the point Q, or it is farther from the point, this point, central point where the plus Q charge is kept. So you have to do the less amount of work in carrying this charge from infinity to point B, and you have to do the more work of charge in carrying it from infinity to point A. So both the work done will be different, and both the work done will be on the same charge. Suppose that here at the point B the potential is VB, and here at the point A the potential is VA. So difference in potential or potential difference, difference in potential or potential difference, VA minus VB. What we have got? VA equal to WA by Q, VB equal to WB by Q. So VA minus VB equal to WA by Q minus WB by Q equal to WA minus WB by Q. Now the change in potential, that is denoted by delta, change is denoted by delta. So delta V equal to delta W by Q. So V equal to W by Q. V equal to what? It is W by Q. That's all for today. We will meet in the next class. Thank you.